So today we are talking about scatterplots. And the goal of scatterplots is still to summarize data visually. But here, the type of data that we're summarizing is called bivariate data. B-I-V-A-R-I-A-T-E. So the prefix bi means two, like a bicycle has two wheels. And variate sounds like variable. All that is it's data that has two variables. And a scatter plot is super easy to draw. You just take the data and plot it like any other XY ordered pair like you would on a coordinate plane. So let's go ahead and look at an example. This data is trying to relate how many hours people studied for a test to their score on the test. So this person, Alexis, who studied for 4 hours and made a 60, we can see the ordered pair 4, 60, plotted right there. Becca, who studied for 1 hour and scored a 30, we can see 1, 30 plotted right here, and so on. So what we want to do now is use the points on the scatter plot to create what's called a line of best fit. Also sometimes called a linear best fit model. And all that is a line that tries to kind of follow the trajectory of those points in order to give you kind of a summary of what those points tend to be doing. Now, if you actually tried to draw a line connecting these points, you wouldn't be able to get a straight line. You also wouldn't even get a function because you've got multiple points that have the same x value but different y values. Turn around. That means that these points themselves are not a function, and that's totally okay. I mean, there is some expected variation in how many hours you study versus what your score is, right? People just do differently on things, and that's fine. But what we're trying to do is just create a pattern that goes through these points. And the way we're going to do that is on our TI calculator, do something called a linear regression. So the steps are pretty similar to what we've been doing on our TI calculators already. We're going to go to Stat Edit and then type in all of the data. However, this time we've got two variables that we need to type in. We're going to type all of the hours studied in L1, meaning the 4 through the 2 and this 3 through the 8. There's 20 numbers to type into the first column, and then in the L2 column, these 20 scores. Now, I probably got stuff already typed in from my last class, so I'm going to go ahead and clear my calculator by saying second plus 712 to clear that RAM. Again, that is second plus 712. Carefully type all of the hours studied in L1. And then whenever you hop over to L2, be really, really careful. Make sure the score that corresponds with the hour studies is right beside it. If you get off, it's going to mess up everything.
How do you reset your calculator?
Second plus 712. So you don't need to do this with your calculator, but I do see that now I've typed in all of these points, matches up with what I've got printed on the paper. Again, you don't need to actually have this on your screen. So what I'm going to do now is try to find the equation of a line that kind of follows those points as best as I can. So it looks something like this. Okay? To do that, going back down here, step 3 says press Stat again, then use the right arrow key to go over to the Calc menu, and then instead of that first option, we're going to go down to the fourth option, Lin Reg. It's going to take you to this screen with the X list, Y list, frequency list, store, and calculate. Just hit enter until you get down to calculate. I think I made a typo somewhere. There we go. So when you get to this screen, you're not going to write these numbers down every time, but I do want to write them down just once. We get A equals 7.891750,327. B is 23.670888608. What these two numbers are trying to give us is the equation of a line in the form of y equals mx plus b that follows these points. And of course, we're going to round this off. Usually, a good rule of thumb for rounding off for data is if you have data that doesn't have any decimal places, just round it to 1 decimal place. So I'm going to round this off to 7.9 and 23.4. And so the equation is y equals 7.9x plus 23.4. Wait, I don't know why I said 23.4. It'd be 23.7, thank you. So, now that we've got that line, we can use it to make some predictions about scores, and we can interpret kind of the overall pattern of these scores. Going back up here for a second, again, you don't need to have this in your calculator, but if I go to the graph, I've actually got it plugged in here where it'll go ahead and draw the line for me. You don't need to worry about actually drawing it perfectly, but do just kind of sketch the general trajectory of this line. It should have a y-intercept of 23.7. So your line of best fit looks something like that. Again, we're just eyeballing it. We're going to let the calculator have the perfect line. So A and B are asking us two really similar questions. A says, use the line of best fit to predict the score of a student who studied for 5 hours. Well, the hours studied is the x-coordinate. The hours studied is the x-coordinate. So that just means plug 5 in for x for this function we just got. So the function is y equals 7.9x plus 23.7. I'm going to plug in a 5. Type that in your calculator and you get 63.2. So you'd probably expect someone who studied for 5 hours to make a 63.2, give or take. Next one, very similar. We're studying for 10 hours now. So y equals 7.9 times 10 plus 23.7. We get 102.7. These two words, interpolation and extrapolation, just refer to what type of prediction you're making. Interpolation refers to values that are inside the range of your data. We didn't actually have anybody who studied for exactly 5 hours, but we did have people who had studied for 4 and 6. And so 5 is considered inside our data. Our data goes all the way from 1 hour up to 8 hours. And so this 63.2, which I can plot it on the line right about here, sort of feels good. The other one is called extrapolation. We didn't have anybody who studied for 10 hours or 9 hours. The most we had was 8. And so this 10, 102.7 is a little bit sketchier because, I mean, well, for one, you might only have a maximum score of 100, not 102. Okay? The further out you go with extrapolation, sometimes your numbers get a little sketchy. Not too much to worry about there, though. Okay, scrolling on down. C and D are the hardest types of questions because they're asking you to interpret stuff. C says, what is the meaning of the slope? First off, what is the slope? .9, very good. So, the slope is always referring to how much the y values change as the x values go up. So, the x values is how many hours studied, and the y value is your score. The slope of 7.9 says your score goes up by about 7.9 points for every hour studied. So again, your score should increase by around 7.9 points per hour spent studying. It makes sense that the more you study, your score is going to go up? Cool. The rate at which it goes up is approximately 7.9 points per hour, based on all the information we currently have. D says, what is the meaning of the y-intercept? Well, what's the y-intercept? 23.7. So the y-intercept of 23.7, right about here, would be 0 hours, 23.7. All that tells you is that your starting value, your initial amount, if you didn't study at all, means you're probably going to make around a 23. So, someone who doesn't study probably make around a 23.7 on the test, based on what everybody else has made. Again, that's give or take. This is just a prediction. How are you feeling so far, y'all? Okay, on the back, we can use Scatterplots to estimate what's called the correlation, C-O-R-R-E-L-A-T-I-O-N, between two variables, which is just how strongly they appear to be related to each other. So here's some examples of what scatter plots with different types of correlations look like. A perfect positive correlation is just going to be a bunch of points in a straight line. And if you connect those dots, it's going to have a line that has a positive slope. The more spaced out these points get, the fuzzier that line becomes, the weaker the correlation, to the point where here, there's just really no clear line at all. And so it just has no correlation. Then over here, if the points tend to cluster into a line that looks like it would have a negative slope, it's going to have a negative correlation. Over here, there's a pretty clear pattern here. Just because there's not a line that goes through all of those doesn't mean that there's a problem. It just means that the correlation is probably not linear. So let's look at a couple of examples. These two examples are really, really close to what you're going to see on your paper after this. So we've got a smaller set of data that we want to start by drawing a scatter plot and determining the linear best fit model. So first off, I'm going to have to kind of eyeball and estimate these numbers. These are relating the number of teaspoons of sugar that are added to a cup of coffee and the overall calories in that cup of coffee. Everybody with me? So, a cup of coffee that had 5 teaspoons of sugar looks like it has 78 calories. So 5, 78 would be right here just below the 80. $1.21 is right one and up just above the 20. $3.55. $2.36. $5.79. $4.61. And keep going. Again, we're eyeballing it here. These points are pretty hard to plot. We're not too worried about having a perfect picture of a scatter plot. Okay, describe the correlation. Would you say that that's a positive or a negative correlation? Yeah, definitely a positive, and a pretty strong one at that. If I use a pencil to kind of show the trajectory, I mean, that pencil pretty much covers all the points. There's nothing too far away, so I would call this strong positive. B says model the data with a linear equation. That's where I'm going to go back into my calculator and reset it. Second plus 712. Stat edit, and then type in these numbers very carefully. Then stat calc fourth option. You can also just press the number 4 to automatically select it. I'm getting this. So again, because none of those values had any decimals, I'm just going to write it off to 1 decimal place. So how about y equals 13.9x plus 10.5. We didn't have any cups of coffee that had 10 teaspoons of sugar in it, but we can estimate how many calories there would be in there by just plugging 10 in for x. So take that 13.9x plus 10.5 and plug 10 in. Comes out to 149.5. Okay, the meaning of the slope of this model. Now, I'm just going to free-handedly draw this graph right quick. Again, we're just eyeballing a line of best fit here. But the calculator told us the slope is 13.9. Remember, the slope describes how much the y values change as the x values go up. So the number of calories in this coffee goes up by 13.9 for every teaspoon of sugar. I think a good way of saying that is each teaspoon adds 13.9 calories. Sound okay? The y-intercept is always your starting or initial value, and it just describes whatever happens whenever the x hasn't changed from 0. So, if there's 0 teaspoons of sugar, the y value is still 10.5. So it looks like without the sugar, the coffee still has 10.5 calories in it. Sound okay so far, y'all? Okay, let's draw one more together. Number 2, the height in inches of a candle can be related to how long the candle's been lit. Some data is recorded below. Draw the scatter plot and then draw the linear best fit model for the data. So I'm going to go ahead and plot these points. This one I don't even have to eyeball. We've got 310, 7.4, 6.4. So what that tells me is these are all different candles, because one candle took 6 hours to burn down to 4 inches. Another candle took 7 hours to burn down to 4 inches. There's just going to be some natural variation here. Would you describe this correlation as positive or negative? Yeah, definitely negative, and pretty strongly negative. Okay, everybody grab your calculator. I want you to type in these data values and see if you can get the linear model. We'll compare answers in just a second, but I want to see everybody typing this in. Make sure you reset your calculator so that none of the questions about the coffee, or none of the data about the coffee cups gets in there. And don't be surprised if your slope is negative. I mean, we already said that there's a negative correlation here. So that first number is probably going to be negative. Anybody got the answer? Want to shout it out? Perfect. Negative 1.4x plus 13.5. To figure out the candle, the height of that candle after 9 hours, just plug a 9 in for x. So negative 1.4, plug in 9, plus 13.5. It's going to come out to 0.9. Does it make sense that after 9 hours your candle's probably going to be pretty short? Yeah, because as a candle burns, it's going to get shorter over time. And that leads me to D. What is the meaning of the slope of the model? The slope is negative 1.4. What that means is as the hours go up, the height of that candle goes down at a rate of 1.4 inches per hour. So something along the lines of the candle burns down 1.4 inches per hour. Sound okay? The y-intercept represents your initial or starting value. Here that would mean nothing has been burned. It's been burning for 0 hours. So what do you think? Yeah, the candle was 13.5 inches tall to start with. I got one more paper to give you. The first 2 questions are exactly like what we just did. I mean, really, I copied and pasted the template and then made a new story. The first one's going to be talking about the number of questions that are missed on a test as it relates to how many hours have been practiced. The second one, this says number 3 because originally it was number 3, but then I cut out number 2 and it didn't change the number. This is a person named Ryan who went fishing, and at different times he measured how many fish he had caught. So one day he went fishing for 4 hours and caught 8 fish. Another day he went fishing for 4 hours and caught 7 fish. That is natural variation. It's going to happen. You don't always catch 4 or 8 fish every time you go fishing for 4 hours. On the back, you've got 2 sets of data that are comparing Barbara and Kenneth, who are on some exercise plans. It's comparing how long they ran on a treadmill to how many calories they burned. Guys, I'd really recommend working with a partner so that one of you can type in this data for Barbara, get your scatter plot, and write your y equals whatever model here. And then the other person type in Kenneth's, make his scatter plot, and write his equation here. You don't need to write whether they're positive or negative or strong or weak. They're both going to be strong positive. Then a couple questions that are comparing and interpreting what those 2 equations come out to be. Sound okay? Again, definitely work with a partner. You can divide and conquer and get this data put in quicker. All right, y'all, let me know if you need any help. I'll be glad to help you.